Hi friends, welcome to Basic Electrical YouTube channel. So in this video I am going to explain solutions for numericals for basic electrical engineering. So I am providing solutions for model question papers uploaded by the university for this particular subject. Now in this video I am explaining solutions for module 4. Module 1, module 2, module 3 already uploaded. Okay, please watch those problems if time permits. Okay, so got it. So don't ask you are uploading late because university uploaded model question papers just for 10 days before. Okay, friends, let we can start first question under module 4. This question came in set 1 model question paper and they are asked for 6 marks. So this problem is knowledge based. If you have a subject knowledge, then you can easily solve it. Okay, and little bit difficulty is there. Okay, information is not clearly given in the question. Even though such condition also we can find solutions. Okay, by knowing some subject concepts. Okay, see, whenever you are solving problems on induction motor, you must remember the following formulas. You apply those formulas, 100% you can solve it. Okay, got it? Let's see. See, induction motor runs at 2 speeds. One speed is nothing but synchronous speed. The equation for synchronous speed is 120 F by P. F is called frequency and P is number of poles. Okay. See, this Ns is also called speed of rotating magnetic field. And another speed is called rotor speed. Another speed is nothing but rotor speed. Induction motor runs at 2 speed. One is called synchronous speed and another one is rotor speed. The difference between synchronous speed and rotor speed is called slip. In theory they will ask define slip. You should define like this. The difference between Ns minus N is called slip. See, while solving problem they are going to ask determine percentage slip. Determine slip only. Okay. Whenever they ask to determine percentage slip means you must remember this formula. Ns minus N divided by Ns multiply by 100. Okay. If they ask percentage slip, then remember this formula. Absolute slip. If they ask absolute slip, then you don't write 100. Okay. You should write like this. This is called absolute slip. Answer will be in the terms of fractional digits, okay, in terms of decimals, and this is in terms of percentage. If they ask determine percentage slip means use this formula. Determine slip means use this one. Okay, got it? So after that we are going to use one more formula, that is called rotor frequency is equal to slip times of supply frequency. Fr is equal to Sf. How we got this formula, that and all you go and watch regular video lectures. Okay, by becoming channel member. Okay guys, Fr is equal to Sf, and if I know synchronous speed and slip, by knowing synchronous speed and slip, I can also find rotor speed. For that formula is N is equal to Ns into 1 minus slip. 1 minus slip. Got it? Only these formulas we are going to apply in induction motor. Okay, module 4 for induction motor solving problems we are going to apply only this much. Okay, how much time it takes to remember this? Okay, you can easily remember it, but importance is how you are applying all these equations in the problem. Okay, that you should get practiced well. Okay, fine. So next is important conditions. Okay, note, you must compulsorily understand this note. So this problem depends on this note. Okay, so when it is called induction motor, see, if your Ns value is more than N, okay, then only it is induction motor. Okay, got it? And then another condition is for good induction motor, okay, a good designed induction motor, you should get the value of slip is from 0.01 to 0.05. What is this? Absolute slip. Your answer of absolute slip should lies within this range. Then it is called good induction motor. Okay. Same thing, if it is in percentage slip, then it could be 1% to 5%. You should get the slip value within this range, 1% to 5%. So this is for good induction motor. Okay, got it? Understood? So please pause the video, copy down all these equations at one side. Okay, in your notebook. Got it? I am going to use the same problems, same formulas while solving this problem. Okay guys, please pause the video and then copy down. So good induction motor, what should be the slip? 1% to 5%. And to become induction motor, Ns value should be more than N. So now let me read the question. A 12 pole 3-phase alternator. Okay, they given alternator. Just now we write the formula for induction motor. Don't worry. We can read question further. Is coupled to an engine and running at 500 RPM. Okay, there is an alternator. Okay, this alternator is having 12 poles. Okay, this alternator, what do you mean by alternator? Mechanical to electrical is called alternator. This alternator coupled to mechanical input, that is engine, and alternator runs at a speed of 500 RPM. See, alternator runs only at one specific speed, that is called synchronous speed, but induction motor runs at two speeds. Now this is induction motor. This another side I am writing induction motor, IM. See, this what do you mean by motor? Electrical to mechanical. See, for this induction motor, I need electrical output. I need electrical supply to run this motor. Where I am getting electrical supply? From the alternator. What is alternator? Mechanical to electrical. So it is going to produce some electrical output. Okay. Output of alternator is given input to the induction motor. So what is this output? It is electrical voltage. Okay. At certain frequency. Whatever the frequency of alternator, same frequency is applicable to induction motor stator. Induction motor, two parts are there, stator and rotor. Stator frequency is F. Rotor frequency is Fr. Okay, got it? So this alternator is supplying power to induction motor. So it supplies an induction motor which has a full load speed of 1440 RPM. So they given whenever this motor connected to alternator, it runs at a speed of 1440 RPM. Whenever they given induction motor runs means that is N value. Got it? So now with this is the data given. Determine the percentage slip. What they are asking? Determine percentage slip and the number of poles of the motor, not alternator. Number of poles. How many poles in this motor and what is the percentage slip? Understand no question? See guys, now I need what is the frequency of this input to this motor. Input to the motor is electrical. Okay, that induced voltage is having certain frequency. I want to find this frequency. To find that frequency, you have to find the frequency from the alternator data. So frequency formula is PNS by 120. What is the number of poles? 12 poles. Speed is 500 RPM divided by 120. Do it in calculator and tell the answer. What is the answer we get from this? 50 Hz. Okay, very good. Okay, 50 Hz. This is the supply frequency. See, this is the electrical output having this much frequency. This electrical supply given to the motor. So what would be the frequency of the motor? 50 Hz. Okay, 50 Hz. Now to calculate percentage slip, sorry, what is percentage slip formula? Ns minus N divided by ns. Okay, multiplied by 100. See, n is given. N is given. Now I need to find ns. I need to find ns. How to find ns? By using this formula. Ns is equal to 120F by poles. 120F by P. To become induction motor, what should be the value of ns? Ns value should be more than n value. Ns should be more than n, then only it is induction motor. So now frequency is given. How much? 50 Hertz. Okay, now find ns. To find ns, I need a number of poles. Poles is not given here. Then how to find ns? Without knowing ns, without knowing poles, I cannot find ns. Without knowing ns, I cannot find percentage slip. Okay, then how to proceed the problem? So you can proceed the problem by assuming some number of poles. And assume the number of poles always even number. There cannot be one pole. Okay, there should be always pole pair. Okay, for every north pole there should be one south pole. Okay, got it? So now look at here. Now I am taking when number of poles is 2. Okay, when number of poles is 4 and when number of poles is 6. I am checking like this. Minimum number of poles will be 2 only. We cannot run the machine with 0 poles. Not possible. Okay, minimum number of poles should be 2. Now take frequency 50 and put the number of poles here 2. Then calculate ns. So 120 into 50 divided by 2 poles. How much you are getting? How much? 120 into 50 divided by 2? 3000. Okay. So 3000 RPM. See, ns is more than n. Yes. ns is more than n. Yes, the induction motor can have 2 poles. Yes, it is 2 poles is possible. Okay. Next, proceed further. Now ns is equal to 120 into 50 divided by, now replace P by 4 poles. Because we don't know how many poles are there. And we are assuming and we are analyzing the difficulty in this problem. Okay. So do this. How much you are getting? 1000? 1500. 1500 or 800? 1500. Okay. So 1500 RPM. See now, ns is more than n. Yes, this condition is valid. See, to become induction motor, ns should be more than n. That condition is satisfied here. So there can be 4 pole also. Induction motor can have 4 poles. Like that also possible. Okay, next finally, ns is equal to 120 into 50. What is the number of poles? 6. Now do it for this one. 120 into 50 divided by 6. How much? How much? 1000. 1000 RPM. Okay, fine. 1000 RPM. Okay guys, now ns is satisfying this condition. What is our n value? Our n value is 1440. To become induction motor, ns should be more than n. But this condition not satisfied here. So you can clearly cancel that number of poles. So now induction motor can have either 2 poles or 4 poles. Okay, but you should select any one pole. Either 2 or either 4. Okay. So this condition satisfied by these 2 poles. 6 poles you cannot make it induction motor for 6 poles because it become ns less than n. Then it cannot induction. Then it cannot be induction motor. Then it become induction generator. When ns is less than n, it is called induction generator. That is not in your syllabus. Okay, leave it. Understood guys? Why I cancelled 6 pole cannot be the answer. Next, check the slip condition. Check the slip condition. What is the percentage slip you should get? From 1% to 5%. Okay, got it? So now I am checking the slip condition. Guys, you should watch the video with lot of patience. Then only you will understand a lot of things. Okay. See now, when poles is 2, what is ns? 3000. When number of poles is 4, what is ns? 1000 500. Okay. Ns is equal to 1500 RPM at 2 poles. Now, see guys, use this formula. I am applying this formula for by using this one. For 2 poles, I am calculating what is the percentage slip. So now percentage slip is equal to Ns. What is Ns? 3000 minus what is the value of N? 1440 divided by Ns is how much? 3000 multiply by 100. Subtract this, that divide by this, then multiply by 100. So how much you are getting? What is the answer? How much percentage? 52. Okay. 52%. Okay. This is the value of slip. Next, check for this one. Percentage slip is equal to Ns is how much? Ns is how much now? For 4 poles, Ns is 1500 minus what is the value of N? 1440 divided by 1500 multiply by 100. Okay, friends, do that calculation. How much you are getting? How much? 4%. Excellent. 4% now. Okay, slip is 4%. See now, speed condition satisfied. With the help of the speed condition, it can have 2 poles or 4 poles. Okay. With respect to good induction motor, what should be the slip range? 1% to 5%. From which one I got 1% to 5? This is the valid selected range to operate induction motor in good manner. Okay, good induction motor. So 52%, it is not in the good induction motor range. So therefore, I cannot opt this type of motor. See, its synchronous speed is 3000. If I purchase that machine with this much slip, rotor speed is very less. Rotor is running at 1440. But what is synchronous speed? 3000. So we are going to lose a lot of mechanical action. Okay. Got it. Now, this one is 4%. So it is selected. So this one is selected. So therefore, final conclusion is, what should be the percentage slip? Percentage slip will be 4%. And what is the number of poles? Number of poles is 4 poles, because in 4 poles speed also satisfied. For good induction motor slip range also satisfied. Good induction motor slip range also satisfied. See how the concept is there. So if any student watch this video completely, definitely they can do much better. See, same type of problem they are going to ask. Okay, they won't give frequency. You cannot find frequency from the alternator data. Under such condition, they will give poles also. They will give poles and they are going to ask percentage slip. Without knowing frequency, you cannot find Ns. Under such condition, you assume frequency. One frequency 50 Hz, you calculate all the details. Next, for 60 Hz also you calculate Ns. Take those two Ns and apply in the slip, good induction motor slip range. Okay, like that also we can do it. Okay, but in this problem, poles is not given. So that's why I assumed poles. It can be 2 poles, 4 poles, 6 poles. When frequency not given, you can assume 50 or 60 Hz. All over the world we have 2 frequencies, 50 or 60. Okay, got it? So please see, final answer is the selected number of poles is 4 poles and percentage slip is 4%. Okay, got it? Okay friends, now we can look into second problem. See, a 3-phase 400 volt 50 Hz supply is given to 3-phase induction motor. Okay, so this is an induction motor. For this induction motor, 3-phase supply is given. Okay, with what is the frequency of that supply? 50 Hz. With 4 poles. Number of poles is 4 poles. With 4 poles running and runs at 1440 RPM. See, runs means, in induction motor, runs at means running or runs at, that is speed of rotor only. So 1440 RPM. I have written the question as it is what asked in model question paper. Okay. See, N is given. Then they are asking determine the speed of rotor. They already given speed of rotor. Okay, so the question has to be corrected in this way. Determine speed of rotor. So this question has to be modified like this. They should ask determine synchronous speed. They should ask determine synchronous speed of the motor. Like that they should ask. Mistakenly they have typed like this. Determine speed of the rotor. Because they already given 1440 RPM. So you should calculate what is the value of NS and frequency of the rotor current. See, whether they ask frequency of rotor, you find FR. Frequency of rotor current, find FR only. Frequency of rotor induced voltage, then also find FR only. Okay, got it? So now, to find FR, I already wrote a formula, simple formula, easy formula. FR is equal to SF. F is given how much? 50. I want to find slip. Okay, now slip formula. What is slip formula? Ns minus N divided by Ns. Okay, now N is given. Now I want to find what? Ns. How to find Ns? Ns formula is 120 F by P. Okay, 120 into what is the frequency? 50 Hertz. Divided by what is the number of poles? 4 poles. So guys, what is the answer? Friends, answer ready? What is the answer? 1000? Still doing? Okay, 1500. Okay, very good. 1500 RPM. I got Ns value. Now take this Ns and put here. So Ns is 1500 minus what is the value of N? 1440. 1440 divided by 1500. Do it in calculator. You will get a slip value 0.04. Check out. I already know this value, that's why I am writing directly. 0.04. You should get a slip answer 1% to 5%. Okay. Suppose in depending on the data given, it can be any percentage. No issue. Okay. 95%. They will give a data in such a way that you should get an answer 1% to 5%. Okay. Some special problems, they can give data anything. So we may get any percentage slip. That is need not to worry. Okay. Got it? 99% they are going to ask correct data. If they given data as they like, you will get the slip as they given according to the data. So fine. Slip I got it. Now take this slip value and put it in this formula. So now FR is equal to, see, slip now. This S, only S means absolute slip. Don't write here percentage slip. If you return 4 here, that is wrong. You should write fractions only. Okay, decimals. 0.04 into what is the supply frequency? What is supply frequency? 50. So 50 into 0.04. How much you are getting? 2 Hertz. Very good. 2 Hertz. So problem is completed. 6 marks will be in your pocket. So this is very easy problem. See. Okay friends, next problem. Question number 3 and question number 4. Okay, problems on alternator. First 2 questions, induction motor. Actually in model paper they asked in one question induction motor, another question alternator they asked. Okay, in both the papers. But I grouped induction motor first 2 problems, alternator next 2 problems. Okay, that is the changes I made it. See, whenever they ask problems on alternator, 100% in your syllabus, problems on EMF equation of alternators only, no other problems. They are going to ask problems on EMF equation of alternator only. So you must remember EMF equation of an alternator formula. EPH is equal to 4.44 F pi TPH KC into KD. Okay, this is EMF equation of alternator. Everything multiplication. Okay. So in some colleges they are going to solve the problems with this formula. Okay. In some colleges, okay, they are going to use this formula 2.22 F pi ZPH KC KD. Okay. This is conductors per phase and this is turns per phase. Okay. They are going to select this formula or this one. Both formulas are correct only. I am going to solve it from this formula. Okay, got it? Understood? Nothing. Because to make one turn, I need two conductors. This equation multiplied by 2. 2.22 into 2, 4.44 you get. That's it. So that's why I am going to erase this one. Okay. Because I am solving problem with this formula. See now, KC and KD, nothing but winding factor. The product of KC and KD together is called winding factor KW. Okay, if they given winding factor, directly you can take KW value. Okay, and KC alone, in that KC is called pitch factor and KD is called distribution factor. In some problems, you have to calculate KD value. Okay, and 100% they won't give problem to calculate KC. All problems on EMF equation of alternator, you take KC value 1 only. Okay, why means for full pitch winding, KC value is 1. For short pitch winding, we have to find KC. Calculation of KC is not in syllabus. That's why they won't ask. Otherwise, they will only give KC value. KC is 0.95. Under that condition, you take KC value. Under that condition, don't take KC is equal to 1 because they already given KC value, you take that only. If not given, take KC 1 only. Okay. And for distributed winding, can find KD. If they given concentrated winding, KD will be 1 only. Okay, got it? When these values will be 1, for full pitch, KC is 1. For concentrated winding, KD is 1. Okay, got it? For short pitch, find KC. For distributed winding, find KD. Okay, but 100% in syllabus, you need not to calculate KC. Take 1 only. If they given KC value, take that only. Okay, got it? Fine. Now, TPH is called turns per phase. Okay, TPH is nothing but turns per phase. Let me read the question. A 12 pole, I am listing out all the data. A 12 pole speed. See, alternator runs at only one speed. That speed is called synchronous speed. What is the value of N is given? 500. What type of connection? Star connection. I am writing Y dot C. That is the star connection. Has 48 slots. How many slots in the motor in the machine? 48. In one slot, how many conductors are there? There are 15 conductors in one slot. Okay, got it? These are the data given. And they given another data. Flux per pole is 0.02 Weber. Flux per pole is 0.02 Weber. E is distributed sinusoidally. Means you must find KD. And also they given the winding factor is 0.97. Whenever they given winding factor, KC, KD together is called KW. This value they given directly. Okay, in this problem. And they are asking calculate line EMF. We have an equation for phase EMF. Okay, once I know the phase voltage, for a star connection, what is the line voltage? That is what they are asking. What is line EMF? What is the line voltage for star connection? Line voltage is √3 times of phase voltage. Okay, once I know the phase voltage, take that value, put it here, you can find line voltage. Okay, got it? Now, KC, KD given in the problem. I want to find TPH. Flux is given in the problem data. Frequency not given. Okay, first to find the frequency. Frequency and the TPH you have to calculate. What is frequency formula? Frequency formula is PNS by 120. How many poles? 12 poles. What speed? Alternator running 500 divided by 120. So we are going to get 50 Hertz. So frequency also calculated. Okay. Next I need TPH. See guys, look at here. TPH formula is ZPH divided by 2. Okay, conductors per phase divided by 2 is called turns. Means this is one conductor, this is another conductor. If I join these two conductor, okay, then it is called one turn. To make one turn, how many conductors required? 2 conductors. That is called turns. Got it? So 50 conductors. Tell it in turns, 25 turns. 10 conductors. How many turns? 5 turns. 4 conductors. How many turns? 2 turns. Like that. That's why I am dividing how many conductors divided by 2, you will get turns per phase. Then what is the equation for ZPH? See, conductors per phase formula is Z by 3. Y means 3 means 3 phase. For 3 phase you take 3. What do you mean by Z then? Z is called total number of conductors. So total number of conductors in the problem not given. So they given there are some slot, in one slot that much conductors are there. So from this you can find total conductors. What is the formula for that? Number of slots into conductors per slot. How many slots in the question? 48. Okay. Into how many conductors in one slot? 15. 45 into 15. How much you are going to get? 720 conductors. We are going to get these much conductors are there in the alternator. If I want to split all these conductors in each phase, okay, then how many conductors we get? Take Z value here, 720 divided by 3. Then we get 240 conductors. Out of 720, in one phase they are putting 240, in another phase 240, and in one more phase 240. Like that, the conductors are splitted. Okay. Now take this ZPH value and put it here. This many number of turns, this many number of conductors in one phase. Then how many number of turns in one phase? 240 is the total number of conductors per phase divided by 2. So there are 120 turns in each phase. In 3 phase, no, R phase, Y phase, B phase. In R phase 120, Y phase 120 and B phase 120. So I got TPH value. Okay, now I got all the data, I got it. Now you write once again formula, nothing will happen. Okay, 4.44 F by TPH, KC and KD. Now enter all the values. 4.44. What is the frequency we calculated? 50 we got. And what is the value of flux given? 0.02. What is the number of turns per phase? 120. What is the winding factor? 0.97. Okay. So from this, how much voltage we are going to get? Okay, what is the answer going to get? 500 and please multiply all this value. Okay, 516.816 volt. Okay, this much is the phase voltage. But what they are asking? Line voltage. For line voltage, for star connection, what is line voltage? √3 times of phase voltage. So therefore, EL is equal to √3 into phase voltage. So guys, how much you are getting? √3 into 516.816. How much you are going to get? 800 how much? 95. Okay, 895.15 volts. Okay, if you want you can calculate. So you are going to get same value only, √3 into 516.816. Yes, getting 895.15 volts. Okay guys, see this problem is direct problem. Am I done anything? Formula is there. I just explained how to find the remaining parameters. Okay, got it? They won't ask calculate phase voltage. They are going to ask line voltage. Same problem. If it come in real time exam, they are going to replace star connection by delta connection. Will you able to do? See, everything till here it is same. Everything is same only. Delta connection. What is the relation between line voltage and phase voltage in delta? Both are same. So therefore, the line EMF will be same as phase voltage. Same question if they change connection delta. Okay. So let me write star only because I have done everything for star. Delta means everything will be same. Only in the final step. finding EL, EPH will be same. See, such changes they can do it. Okay, got it? You should be perfectly prepared. Okay, what changes they are going to make? You must know all this relation. Where you are going to study all this relation? In second module, three-phase circuits. So that is also applicable in each and every module. Okay, what are the topics you studied in previous module? It is applicable in upcoming modules. Okay, got it? Pause the video and then copy down. This is same as previous problem only, but here I am going to explain how to calculate KD value. Okay, let me see. A three-phase 16 pole. Okay, number of poles is 16. Alternator has a star connected winding. Okay, so they given star connected winding. Has 144 slot. How many slot? 144 slot. In one slot, how many conductors given? 144 slot and 10 conductors per slot. In one slot, there are 10 conductors. The flux per pole is given 0.03 Weber. Okay, unit of flux is Weber. And the given sign distributed. See, sign distributed means sinusoidally distributed. Means you have to find KD. Okay, and they are asking another data they given. The speed is the alternator running at a speed of 375 RPM. And they are asking find the frequency. What is frequency? What is phase and line voltage? Phase voltage is how much? And what is the line voltage? So if you know the phase voltage, what is line voltage for star connection? Root 3 times of phase voltage. Very simple. Okay. And see, KD I want to calculate. What about KC? So KC is not given. You can take KC is equal to 1. Directly assume KC is equal to 1. Because full pitch winding. You are assuming full pitch winding. KC is 1. Okay. So now let me calculate KD. Okay. So to calculate KD, the formula you have to remember this one. Sin m beta by 2 divided by m into sin beta by 2. Okay, very simple problem, simple formula. You, while calculating this, keep the calculator in degree mode. Keep the calculator in degree mode. Fine. Because you are doing three-phase circuit problems, single phase and three-phase, your calculator should be in complex mode, and in the same mode, if you are calculating this, you will get wrong answer. Okay, please keep it in degree mode. Okay, degree and computational mode, not complex mode. Fine. See here, again two unknowns are there. What is m, what is beta? See, m is nothing but slots per pole per phase. Slots per pole per phase. Means, how to find m is, first you take slot, okay, divided by number of poles. Whatever the answer getting from this, divide that answer by phase, number of phases. I am going to do that. What is the number of slot? 144 slot. Divided by how many number of poles? 16 poles. Okay. Pole divided by how many number of phase? 3 phase. If they given 5 phase, take 5. That's it. They won't give. They will give 3 phase only. Now 144 by 16. 16 9 ja 144. 9 by 3 is how much? 3. They will give data in such a way that you will get m value exact integer. Okay, they won't give data, you are going to get m value 3.33, 4.5 like that. Exact integer like that only they are going to give. Next, beta. Find beta. See, beta is nothing but slot angle. Okay. So, slot angle formula is 180 degree divided by n. And here, small n is nothing but the ratio of slot to pole. Okay, slot per pole is nothing but n. How many slots? 144. How many poles? 16 poles. What's the value of n? 9. Now, take this n value and put it here. You will get a beta value. 180 by 9. We get beta 20 degrees. Beta value is 20 degree. Now, in this formula, m value is how much? 3. What is beta value? 20. From that, find KD. So I am going to find KD now. So KD value will be sine, I am writing the value directly. What is M value? 3. Into what is beta? 20. Sine M beta by 2 divided by M sine beta by 2. M is 3 into sine beta by 2. Beta is 20. 20 by 2. See guys, you should get KD value within 0 to 1 only. Your KD value never become negative and KD value not be more than 1. Then what is the answer? Your answer should come from 0 to 1 only. So I am going to do this one. Okay. And the answer will be almost near to 1. Okay. So let me do this. Sine M beta by 2 divided by M sine beta by 2. So we got the answer 0.9597. You write the KD value after decimal up to 4 digits. So it gives an accurate result. That's why. Okay. Got it? That is KD value. So that is the only thing we are going to calculate in detail. Okay. Now you write formula. Okay. EPH formula is what? 4.44 F pi TPH KC into KD. KD you got it, you substitute there. KC is 1. Flux is given. Flux is given 0.03. Frequency you have to find. So finding frequency, I am going to do it here. Frequency formula is what? PNS by 120. So how many number of poles? 16 poles. What speed the machine running? 375. Divided by 120. So you are going to get how much? Please do it. So 16 into 375 divided by 120, getting 50 Hertz. So frequency is 50 Hertz. Got it? So frequency calculated. Flux is given. Now I need TPH. So again same logic. What is TPH formula? ZPH by 2. What is ZPH formula? Z by 3. And what is Z formula? Slot into conductors per slot. Okay. How many slot? 144 slot. In one slot, how many conductors? How many conductors? 10 conductors. So 144 into 10, how much? 1440. Very good. 1440. This is what? Z value. Take this Z value and put it here. So ZPH is equal to 1440 divided by 3. How much you are going to get? 1440 divided by 3. 480 we got. We got 480. Now take this ZPH and put it here. 480 divided by 2. How much? 240. What is the value of TPH? 240. So TPH value is 240. Now I got everything. And now I am going to put it in the formula. So 4.44. What is frequency I got? 50 Hertz. What is the value of flux? 0.03. So see, flux value from the data 0.03 into TPH is 240. KC is 1. KD is 0.9597. So from this you will get a phase voltage. Let me multiply. 4.44 into 50 into 0.03 into 240 into 0.9597. So getting 1533.98. So I am going to approximate this as 1534 volts. Okay. I am writing round up value 1534 volts. I calculated. Phase voltage is calculated. Then what is next? Line voltage. What is line voltage formula? What type of connection you should observe when finding EL? Star connection, no. Line voltage is root 3 times of phase voltage. Root 3 into this. Okay. 1534 multiplied by root 3. So from that I am getting 2657. So 2657 volt. This also I wrote approximately. You will get 56.9 something. So I wrote 57. Okay guys. By this, the module 4 model question paper solutions for basic electrical engineering subject for 2 model question paper is completed. From the 2 model question papers, they asked for finally 4 problems only. I given solution, in detail solution for 4 problems. Those who don't know how to solve, that is the reason I explained. Otherwise, I could have do a 2-minute video, only writing question and solution. Okay, so that is not correct way. Okay, so understanding is important. If you have a time, please watch it. Okay, got it? So if you like the video, please give a like after watching the video. Okay, don't give starting only, watch entire video, then you like, and share this content to your friends. Okay, tell them to watch it if they are free. Okay, got it? Because exam time, we need not to force anyone. Okay, if they need it, they are going to watch it. So meet you on next video, module 5 numericals. In module 5, university has given only one problem. In both sets of paper, only one problem. I am going to add additional 3 problems, and that you study only those 4 problems. Within that only you are going to get it in the exam. Okay, have a nice day. So thanks for watching the video. Meet you on next lecture or tomorrow. Okay, bye bye, take care.